Welcome back to the SOC Analyst course. In this lesson, we're going inside the Security Operations Center, or SOC, and looking at how security operations actually work in practice. When people first hear the term SOC, they often imagine a room full of analysts staring at dashboards and waiting for alerts. And yes, dashboards and alerts are part of it, but a SOC is much more than that. It is a centralized security function responsible for continuously monitoring an organization's environment, detecting suspicious activity, investigating potential threats, and coordinating the response when something actually happens. The important word here is continuously. Security incidents obviously don't care about business hours. An attacker isn't going to wait until Monday morning because your security team went home for the weekend. A SOC is therefore built around three things: people, processes, and technology. Technology gives us visibility and detection capabilities. Processes define what we do with that information. And people analyze the context and make decisions. You can buy every security product on the market, but simply having those products does not mean you have an effective SOC. Modern environments are also huge. Think about how much telemetry even one organization can generate. You might have thousands of Windows endpoints, Linux servers, Active Directory, Entra ID, Microsoft 365, VPN connections, cloud workloads in Azure or AWS, firewalls, DNS, email security, applications, SaaS platforms, and third party services. Every one of those systems produces data, and at the same time, many of them represent potential attack surfaces. Without centralized monitoring, suspicious activity can easily be missed because individual events often don't look particularly interesting on their own. For example, one failed authentication attempt probably means nothing. A successful authentication from a new location might also be legitimate. A PowerShell process can be completely normal. A DNS request is something that happens constantly, but now imagine that the same account generates unusual authentication activity, followed by suspicious PowerShell execution on an endpoint, followed by a connection to a newly observed domain. Individually, those events might not tell us much. Correlated together, they create a completely different picture. That ability to build context is one of the most important concepts in security operations. There also isn't one universal way to build a SOC. Organizations generally use an internal SOC, a managed SOC through an MSSP, or some type of hybrid model. With an internal SOC, the organization owns the security operation. The analysts, management, tools, infrastructure, detection rules, procedures, telemetry, and incident processes are managed internally. The obvious advantage is control. Your analysts understand the organization, its users, infrastructure, business processes, and normal behavior much better because they work directly inside that environment. But this model is expensive. You need analysts, tooling, infrastructure, training, management, and potentially 24/7 coverage. And maintaining enough skilled people to provide that coverage can be difficult. Another option is a managed SOC, usually delivered by an MSSP, or managed security service provider. In this model, an external provider performs some or all SOC functions for the customer. Depending on the service agreement, the MSSP might monitor telemetry, review alerts, perform initial triage, investigate suspicious events, and escalate confirmed incidents. This can provide access to specialized expertise and continuous coverage without requiring the organization to build the entire operation internally. But there are trade offs. An external analyst usually doesn't have the same organizational context as someone working internally. Communication and escalation processes become extremely important, and exactly what the SOC can and cannot do depends on the agreed service scope. Then we have the hybrid model, which combines both. An organization might maintain its own internal security team while using an MSSP for continuous monitoring or after hours coverage. The MSSP could perform initial alert triage and escalation, while the internal team handles advanced investigations, threat hunting, containment decisions, and coordination with other internal teams. In practice, hybrid environments can work very well because they combine external coverage with internal organizational knowledge. Regardless of the operating model, the fundamental SOC workflow remains similar. We continuously monitor the environment. We detect potentially suspicious activity. We triage alerts. We investigate them. If we confirm an incident, we coordinate the response, and then we use what we learn to improve our detections and processes. This is important because an alert is not the same thing as an incident. When a security product generates an alert, the analyst's job is not to immediately assume that the machine is compromised. The analyst needs to determine what actually happened. Imagine your SIEM generates an alert for suspicious authentication activity. The first thing I want is context. Which user generated the activity? What system was involved? What IP address did the authentication come from? Is this a privileged account? Is this behavior normal for that user? Were there previous authentication attempts? What happened before and after this event? From there, I might pivot into identity logs and check additional authentication activity. Then I might move into EDR and look at what happened on the endpoint. What processes were executed? What was the parent process? What commands were executed? Were there suspicious network connections? Was anything created for persistence? Did another process appear immediately afterward? Then I might check DNS, firewall, proxy, cloud telemetry, or threat intelligence. This is why analysts frequently move between multiple security technologies during a single investigation. One of the central technologies used for this is SIEM, or Security Information and Event Management. The SIEM collects security telemetry from many different sources and gives analysts a centralized place to search, correlate, detect, investigate, and report on security activity. A very important part of this is normalization. Different products represent information differently. One firewall might have one field name for a source IP address. Another product might use something completely different. The SIEM attempts to normalize important information so that analysts can search and correlate activity across different technologies. Platforms such as Splunk and Microsoft Sentinel are examples of SIEM technologies, but the important thing is understanding the concept rather than memorizing product names. The SIEM gives us broad visibility across the environment. EDR gives us deeper endpoint visibility. So imagine again that the SIEM detects suspicious authentication. I can use EDR to investigate the endpoint associated with that activity and look at processes, commands, network connections, persistence mechanisms, and other endpoint telemetry. Then I correlate that with authentication logs, DNS activity, firewall telemetry, cloud events, and threat intelligence. At that point, I might determine that the alert is a false positive. I might determine that I still don't have enough information and need to continue investigating. Or I might have enough evidence to confirm that I am dealing with a real security incident, and that decision changes what happens next. Once an incident is confirmed, the SOC moves from investigation toward response and containment. Depending on the incident and the analyst's permissions, that might mean disabling a compromised account, revoking active sessions, isolating an endpoint, blocking a malicious IP address or domain, removing a malicious email, or restricting network communication. But there is another important point here. Not every SOC analyst has permission to perform every containment action. Security operations involve coordination. The SOC might need to work with IT administrators, network teams, identity teams, cloud teams, management, legal, compliance, an external incident response team, or even the affected user. The exact process depends on the organization, severity of the incident, business impact, and established incident response procedures. We also need a way to measure whether our SOC processes are actually working. This is where metrics such as MTTD and MTTR come into the picture. MTTD means mean time to detect. Essentially, how long does it take us to detect malicious activity after it occurs? Better telemetry coverage and better detections can reduce this time. MTTR is a little more complicated because organizations use the acronym differently. It can refer to mean time to respond, remediate, recover, or repair. That is why whenever you see MTTR in documentation or reporting, you should understand exactly how that organization defines it. The goal of these metrics should not simply be to measure how fast analysts click through alerts. They should help us identify weaknesses in the overall process. Maybe analysts are spending too much time manually gathering information from 5 different tools. Maybe escalation procedures are unclear. Maybe the detection generates too many false positives. Maybe containment requires approval from another team, and analysts spend 30 minutes waiting for somebody to respond. Those are operational problems, and metrics can help expose them. Automation can help with some of this, which brings us to SOAR, security orchestration, automation and response. SOAR is commonly used to automate repetitive parts of security operations. Imagine the SIEM generates an alert containing a suspicious IP address. Instead of the analyst manually copying that IP into several threat intelligence platforms, a SOAR workflow could automatically enrich it. It could check reputation sources, identify other systems that communicated with that IP, collect additional context, create or update an incident ticket, and escalate the case when human review is required. Depending on organizational policy, it might even perform predefined response actions. But automation should not be confused with replacing analyst judgment. High impact actions need appropriate controls and authorization. Automatically enriching an IP address is very different from automatically disabling a critical production account or isolating a business critical server. Another framework you will constantly encounter in security operations is MITRE ATT&CK. ATT and CK gives us a common way to describe adversary behavior using tactics, techniques, and sub-techniques. A tactic describes what the adversary is trying to achieve. A technique describes how they are attempting to achieve it. A sub-technique gives us an even more specific implementation of that behavior. SOC teams use ATT and CK for detection engineering, investigations, threat hunting, coverage analysis, and incident documentation. For example, if an investigation identifies a particular attacker technique, I can use that information to think about what related activity I should search for next. It also gives different teams a common language. Instead of vaguely saying that we observe something suspicious, we can describe the behavior using a standardized framework. So when you put everything together, the SOC starts to make much more sense as a complete system. Telemetry comes from endpoints, networks, identity systems, cloud platforms, applications, and email. That telemetry can be collected and correlated by the SIEM. Detection logic identifies potentially suspicious behavior and generates an alert. The SOC analyst reviews that alert, adds context, pivots into other telemetry sources, and investigates. Then comes the decision point. Is this a false positive? Do we need more investigation? Does it need escalation? Or do we have enough evidence to confirm an incident? If response is required, SOAR and other security technologies can support enrichment, automation, containment, ticketing, and escalation. Incident response then moves through containment, eradication, and recovery. And finally, what we learned from that incident should feed back into the SOC. Maybe we need a new detection rule. Maybe an existing detection needs tuning. Maybe telemetry was missing. Maybe our escalation procedure was too slow. Maybe we discovered an attack technique we weren't properly monitoring before. That feedback loop is extremely important. The SOC does not exist simply to generate and close alerts. Its purpose is to take enormous amounts of security telemetry and turn that information into decisions, and then turn those decisions into an effective response. If there is one thing I want you to remember from this lesson, it is that security operations are not about one tool. SIEM, EDR, SOAR, threat intelligence, MITRE ATT&CK, network telemetry, identity logs, and all the other technologies we use are pieces of the same system. The analyst is the person connecting those pieces. And that ability to correlate information, understand context, investigate what actually happened, and make the correct decision is ultimately what makes a SOC effective. In the next lessons of this SOC analyst course, we'll continue breaking these concepts down and move deeper into the technologies, telemetry, investigations, and workflows that SOC analysts actually work with.